Good afternoon, everyone. My name is Brúnó Balázs. My PhD working title is Novel Methods to Optimize Cardiac Catheterization. I'm a PhD student and a medical doctor interested in interventional cardiology. My vision is to enhance the safety of the cardiac catheterization laboratory team by reducing occupational hazards. Therefore, my mission is to provide forward-looking and novel scientific results in occupational radiation safety. Currently, I have two projects underway. The first one is investigating the risk of radiation exposure for different personnel during fluoroscopy-guided cardiovascular procedures. We are conducting a systematic review and meta-analysis. The number of percutaneous procedures to treat cardiovascular diseases has rapidly extended in the last few decades, but those performing these types of procedures have to face severe risk for developing health problems compared to other healthcare workers, and this risk is most related to radiation and radiation-induced illnesses. The association with cataracts is well documented, but there are also growing concerns for radiation-induced malignancies, with reports signaling predominantly left-sided brain cancer among interventionists. As you can see on the figure, the approximate position of the key stop members are fixed, and these positions can determine their risk to radiation exposure. As you can see on the figure, on the right side of the patient, there is the primary catheter operator and the secondary operator, and the anesthesiologist and the interventional imaging specialist usually stand at the head of the patients. Our aim is to examine the radiation hazards between these different personnel in the catheterization laboratory and identify occupations in need of a higher level of radiation protection. So our question is, which personnel have the highest radiation risk? And in our framework, we are comparing the per procedure radiations of the ancillary staff members to the primary catheter operator, with the hypothesis that the workers standing at the head positions have higher radiation exposure than the primary operator, but those standing in the secondary position have lower. I conducted a systematic search in 5 different databases, and during our selection progress we found 36 eligible articles. In our analysis, we are collecting articles that are comparing per procedure dosimetric radiation data of staff members measured in microsievert. Between these studies, they use dosimetry in different body sites, sometimes covered by the lead apron or not, and there can be 100-fold differences between these data based on the type of the procedure, the complexity of the procedure, the equipment they use, or the operator radiation awareness. So we decided to use standardized mean difference, in which way we can unify our comparison. SMD is not tied to any specific unit of measurement, and its interpretation differs from other summary statistics. The literature suggests that an absolute value of SMD between 0 and 0.2 is considered as a small effect size, and anything about 0.8 is considered a large effect size. In this first plot, we are comparing the per procedure radiation doses of ancillary staff at the head positions to the primary catheter operator in 2 different subgroups based on if they did use a shielding device at the head or not. And in the first subgroup where they didn't use any additional shielding device at the head position, the SMD was shown to be 0.65, which means that these personnel have higher radiation exposure than the shielded primary operator. But in the case they did use shielding, the SMD was shown to be negative 0.8, which means that they have lower radiation exposure than the shielded primary operator, signifying a large difference. But it's also important to notice that there is a significant difference between the subgroups with a very low p-value, and we can interpret it in a way that the application of additional shielding device at the head positions create a significantly lower risk of radiation exposure for these staff members. In our second forest plot, we are comparing the radiation, the amount of radiation received by the ancillary staff at the secondary position to the primary operator. Luckily, we were able to make measurements from more than 5,000 measurements, and the overall pooled SMD is negative 1.12, meaning that workers in the secondary position receive lower amount of radiation compared to the primary operator, signifying a large difference between the two groups. As a assessment our results, we can say that the unshielded staff members at the head position have the highest radiation risk. Meanwhile, the secondary position is the safest among of these, and the clinical implication would be that every catheterization laboratory where are workers at the head position, there should be ceiling mounted radiation protective devices or other additional protective devices that should be equipped there. As my progress, we are progressing with the risk of bias assessment, and soon we will be able to start writing the manuscript. My second project is evaluating various types of radioprotective equipment in the catheterization laboratory, and this would be a phantom study, a cross-sectional observational study. As I mentioned earlier, the risks for these workers are known, but unfortunately the worker safety often remains inadequate in these catheterization laboratories. Even though every personnel stepping in to the cath lab is legally obliged to wear lead apron and thyroid collar, but we have to notice that these protective gears primarily shield the torso and the neck, leaving vulnerable areas such as the head susceptible for higher amount of radiation, often 10 to 20 times more. So with the study, our aim to evaluate different additional or supplementary personal radiation protective devices that are made for reduce the radiation of the eye and the brain. And this could offer an insight of the comparative effectiveness of the devices, which can guide the recommendations and safety protocols. For more specifically, for example, as you can see on this figure, the scatter radiation, which is the main component of the exposure of the workers, are coming from below the head. Knowing this, we might think that maybe these extended color protectors are more efficient to reduce brain radiation compared to these leaded face shields where the lower face is open. But we don't know these yet. The protocol is still being drafted, but this is an example of the practical questions we seek to answer with this study. So the question is, which personal radioprotective device most effectively reduces radiation exposure of the head organs for the cardiac catheterization laboratory workers? And we will build an operation model with imaging phantom in the patient position and also in the operator position, and we will make a dosimetric measurement of this mock operator, assessing the evaluation, assessing the effectiveness of these devices, and this can create a ranking between these devices which could be incorporated in the practice, and a more effective application of these devices can reduce the risk of chronic irradiations. So as a summary, our first project successfully revealed who are in the most danger among the workers, and our second project will provide clarification which are the effective ways to protect these workers. I would like to close with Marie Curie words: nothing in life is to be feared, it is only to be understood. Thank you for your attention.
Thank you very much for your presentation, Brúnó. I absolutely love it. This is not a highly researched field in medicine, but I think it's very, very important from my aspect, because I am mostly on the head position as an intensivist, and my colleagues, and we don't have extra protective equipment, just the basic apron, and it's nice to know. Thank you very much.
Congrats, because
thank you.
I have to join you, but I am always at the head position in the cath lab or in the hybrid ward. So the most important question is where to put the dosimeters in the second study. Under the lead apron, on the head, of course, right? Will you use a ring?
The most ideal would be we are in connection with the National Atomic Energy Agency, and they are willing to provide us imaging phantoms. But there are imaging phantoms where you can put a dosimeter inside the brain of the doll. So that would be the most ideal, for example, the headgear, if we could put a dosimeter inside the brain. But also another important part is the eye. There are specific dosimeters that can be attached to the goggles or next on the temple area. Our protocol is still being drafted. Maybe we will do an increment of increment of exposure, and also a range of protective devices applied at the same time. So it's mostly will be based on what the resources are available. How many dosimeters, yes. How many doses. Yeah.
Ask more than you would like to use.
Yes.